Simplified Engineering. This is video lecture number 12 and the topic is Displacement Work and PV Diagram. In the last lecture we covered the concept of displacement work, or it is also called PDV work. In this lecture we are going to discuss what is the relation between this displacement work and PV diagram, how we can represent the displacement work in PV diagram. Okay, in the last lecture we derived the concept, the displacement work W12, that is the displacement work from point 1 to 2 is integral V1 to V2 PDV, and where dV is the differential change in volume and P is the equilibrium pressure at each point. So integral V1 to V2 PDV will give the total work done, total displacement work. Okay, consider a PV diagram. We are already explained the concept of PV diagram and in y-axis it is P and in x-axis it is V. Consider a constant pressure process, means that during that process the pressure is constant. It will be a straight line because at each point pressure should be the same, means the initial pressure is same at each point. So it will be a straight line parallel to the volume axis, so that it will give the constant pressure. So at the initial state the volume was V1 and at the end of the process the volume changed to V2. So we are going to find the displacement work done for this process. So work W12 we can write integral V1 to V2 PDV. Since it's a constant pressure process, means pressure is constant, we can take the P outside the integral. So W12 equal to P into integral V1 to V2 dV. So integral of dV is V, we know, so we can write W12 equal to P into V2 minus V1. So what this equation means, look at the figure here. The P is on the y-axis, which means that with the orange dotted line and yellow process line, again orange dotted line, it is a rectangle. So P is the height of the rectangle and V2 minus V1 is the length of the rectangle, which means that we are multiplying this height into length or length into breadth. So what we will get? We will get an area, which means that work done in this process is area of the PV diagram or area under the process. So we can conclude that the displacement work is area under PV diagram. In this case we describe the constant pressure process. What about the other processes? What other processes such as constant temperature process, constant volume process, etc. So in general, whatever the process is, it is from V1 to V2, the area of the PV diagram is work done or displacement work. This is a constant, which means that area under the PV diagram is displacement work. Okay, another point is that work is a path function. What is mean by that? Which means that the work done, which is the area under the process curve or path, so the work done depend upon the path in which it followed. It doesn't depend upon the initial and final point, it also depends upon the path through which it is gone. I will explain. Consider the PV diagram. The initial point and final point is denoted V1 and V2. This is one possibility, this is a one process. So the area under this yellow lined curve process, that is the work done in this process. For the same end condition V1 to V2, the orange curve, that can also be a one process. So area under that is a higher work done because it has higher area. And another one, this is one more case in which the area under this white line is the work done in that process. So whatever the initial and final conditions, whether it is same or not, the work done may vary. So it depends upon the path in which it is followed. Okay, so work is called a path function. It depends upon the path through which the process occurs. So we are going to conclude this lecture. In this lecture we covered the concept of a PV diagram and what is the relation between displacement work and PV diagram. It is simply the area under the PV diagram is work done, And another thing, work is a path function. It depends upon the path through which it is followed. Okay, in next video we will be covering the displacement work in a solved example. We will be solving with animated video a numerical problem. You can understand the concept very well through that. You can subscribe for latest videos. Thank you for watching. Thank